we have battery that has issues. So let me just show you. So we have this battery that has issues. This is what a normal one looks like, right? So one of these has been chewed up. What is these leads called? Yeah, the balance part. Okay, so that's been chewed up. And that happens because you don't secure these and then the propeller like cuts it. All right. So this is pretty dangerous right now. That's why I had to individually tape each of these, because if they touch each other, it's going to short out, create a spark. Do you remember what type of connector we use on the balance port? Huh? Let's look it up. JST XH right here. XH. And specifically, what type of battery do we have right here? How many cells?
4.
So then how many leads do we have coming out? 5. So then we need to get a JST X, which I have right here. I bought a kit on Amazon. It's like $10. It comes with a bunch of these. You see that there's different number of pins. So we need to find the one that's 5 pin, which is
10 pieces. Bottom right corner.
bottom right corner. Yep, there it is. We need the male one. Oh wait, do we need the male? No, we need the female version. Okay. Oh, okay. This labeling is actually kind of, the label is kind of different. Okay, we're gonna use this one, even though it says male. Okay, for our class, we're gonna say it's a female, but they labeled it differently. And then specifically JST XH, which kind of defines the shape, but there's also the spacing between the pins. So for us, it's 2.54 millimeters. That's the spacing from pin to pin. Just to clarify what I mean by that is, if you look at this image right here, you see how I specified in this example, it's 2 millimeters pin to pin. So you can actually take a caliper ruler and you can measure one of these and verify it's 2.54 millimeters. Okay, so now that we have the right one, we're going to replace the. I already tore out the like actual plastic housing, so we're going to put a new housing in. But we have to put it in a specific order, because if you look here, you see the way that the cells are laid out. We have to do it like sequentially. We can't crisscross, otherwise it's going to be an issue later when we charge it. Let me demo if we were to do. Let me see if I can find one that's bare, because there. I'm just going to do it from scratch again. I'm going to clip these, and I'll leave. There's enough to go around if people want to like try your hand at it. But it's like a 2-step process. The first thing we need to do is we need to get the wire exposed. Just strip the end. Then we need to put on a pin. Let me see if I can isolate one of these. Okay, well, this is what's left of the remaining thing. But you can see right here, we have the metal pin on here. So that's what this row of pins right here is for. You slide this onto the exposed wire end. Then you need a crimping tool right here. So this crimping tool is going to allow us to clamp down on it, onto the wire, and then you can slip on one of these. Okay. Perhaps it'll be easier if I just showed a video of what's actually going to happen, because it's going to be a little difficult for me to probably show on JST, or I'll just say crimping JST. Okay.
What do you call those things that was on that metal strip? You break them off and you attach the wire to it?
They're just called pins. Yeah, they're just called pins. Yeah. Let me see if
To make JST
video,
connectors,
so
the
I'm just
best
gonna
tool
see if
for
this is-
crimping is this one.
Oh, that's exactly the same tool I have. There's different size crimpers. So like back in the corner, they bought the wrong type, thinking it was just a normal crimper. But this is like pretty small. If you I mean, if you look at the teeth here, it matches like the sizes of what we're talking here, like 1 millimeter. So those bigger crimpers, like if you're actually doing electrical, like bigger electrical work, but we're doing much smaller one.
Before you start, break the connectors off from the carrier.
So yeah, okay.
The most useful ones.
I guess the audio is not playing through here. Let me.
For our purposes are these ones, since they can connect both to ordinary header pins as well as to proper JST type PCB mounted sockets. Remove the insulation to have exactly this much copper for crimping. Only the wings in the middle are supposed to grab onto blank wire. The rear wings will be holding onto the insulation, and no wire at all should go beyond here to make sure there's room inside the receptacle to accommodate the pin. For crimping, we'll use 1.4 and 1.9 millimeters. Hold the pin like that, insert it exactly like this, with the middle wings in the crimper, and then insert the blank copper part and crimp it.
Do you guys see that? Sorry, let me scroll back. Oops, did I mute it? I think I muted it.
Crimp it.
Okay, right here, the little folds. So previously it was like outwards wings, and then with the crimping tool, it like curls it up and it folds it into the middle. So first thing he did is they just crimped the bare wire to the actual pin, and then they're probably going to do the outside one now.
To slightly close the wings for the insulation, then insert that into the 1.9 millimeters and also crimp it.
There it is.
Question.
Yes.
It looks like the ends of the wire were tinned. Is that necessary or recommended?
I don't think you need to tin it. It might help if you want to keep the strands together, because you do want to like crimp everything into it. But they didn't mention tinning in, at least when you normally.
That's why I'm asking.
Oh, look tin.
It looked tinned because I
It-
done that and I didn't tin my wire.
Okay, I mean it's possible it's tinned. If you do it like straight, like freshly cut before you had a chance for the wires to start to fray, then I think it'll be okay without tinning. But feel free to if you want.
If you do a bad crimp, will you have to just snip it and restart?
Yeah, you basically do. Yeah, but you're not losing that much wire. So actually what I'm going to do is I'm going to do exactly that. I'm just going to trim like right here, like right at the base of the existing wire, and then I'm going to so I lost like maybe, I don't know, like 3 millimeters, so it's not a big deal. But yeah, it's too difficult to like uncrimp the thing. Mm-hmm. Yes.
Those outer wings actually end up going through the shielding and touching the wire.
That's a good question. So your concern is like it's actually puncturing
I mean,
the.
it's not a concern, it's just an additional
Actually, I don't know.
job.
Yeah,
Because it kind of looks like it there.
I think it does. It does puncture right into it. Yeah. So.
I think it depends on your crimper.
Yeah, because the shape of this thing, if I was to draw it, like the shape of this thing is. The shape of this thing looks like this. Well, okay, so inside the crimper we have something that looks like this, and then that's the male portion, and then the female portion have. Oops, let me look at that. It has something like that. So then it's gonna force your wire to like curl like that. In red, you see that? Yeah. So that's kind of, and then here's the blue is gonna be your actual like wire right there, or maybe right here. I don't know. It's like really tiny. Like I'll pass this around later if you want to practice crimping, but you can see it in action. Okay, so I've already done it on one of these. You can see right here, and I've actually left this intact because it helps preserve the orientation. Remember, we need to have the wires in the right position. I mean, this is not the most sure way, but it's pretty close. Like you could just see coming out of the battery, like I see this very right wire is probably the very right one. So And then these other ones are all kind of lined up just like that too. So I'm just going to keep those orientations. Now, you see right here, it's best if you have an existing battery to compare with. So I can see right here that I need to line up the red with the teeth of that little piece. So right here. So instead of this end, instead of putting the red like this, the red needs to go over here. So the orientation matters here. This one's actually pretty straightforward. Since the pins themselves are fine, I'm just going to preserve it. There's no need to redo it. I will probably have to redo it on the other ones. Let me get a toolkit. So in this toolkit, I'm just grabbing a small flathead screwdriver. And what I'm going to do is, there's a little metal, let me see if I can show it. Do you see right here where there's a little metal hook there. That's what's holding it in. So I can kind of, let me see if I can just depress that little metal hook, and then that would allow me to slip the thing out. It's like a barbed wire. So right now I'm just kind of trying to press, okay, there it is. See if I can show, you see the profile? You see the little metal hook? There it is. Okay, so before I lose this thing, let me slip it into the position it should be. It should be right here. There it is. Oh shoot, I did it backwards. Oh, okay. All right. Let me undo that. Yeah, I mean, I don't want to keep flattening the hook too much. Otherwise, it's going to not work anymore. So I'm just going to make sure the hook is still there. The hook is just a piece of like metal that's just been lifted up. So I can just kind of lift it up again some more. Okay, there it is. I've restored that functionality. Okay, this is how it's supposed to go. It's supposed to go like this. All right. Okay, so there it is. The two are the same now. Okay, let me do, I'll do the other hook.
Can you bring your video back closer?
Oh, I'm so sorry. I had no idea. So you missed that whole part, huh? Okay, well, there it is. Okay, the hook has now been kind of destroyed a little bit. I'm just going to push it back in again. Okay, put it back in. All right, I'm just always tugging it once I put it in just to make sure it actually seated properly. All right, let's take a look to see if the other ones... Okay, these other ones are also still intact. So I'll just leave this battery for someone else to give it a shot, because I want to show the actual like crimping portion. So let me move to another battery that actually needs some crimping. So this battery needs some help because it's been very much destroyed. Okay, this first one I'm going to do is this one right here. Here, you can look closely. Let me see if I can zoom in again. Okay, well, I'm gonna first clip this. Let me clip it right at the base so I preserve as much of the wire as I can. And only work with one at a time because this battery is still on. I mean, there's no off button on it. So, okay. There it is. I'm just going to twist these wires together. That way they don't come apart. They stay together. I need a blank background so it doesn't lose focus. All right. I'm just going to take off one of these pins. You just bend it back and forth until it rips off. Okay, so I need to make sure that, if you recall in the video, they said not to, there's 3 zones of this crimp clip. Okay, there's 3 zones. There's 3 zones of the crimp clip. I'm going to point it out. So this is the end that's actually going to go to the pin on the receiving end. This is one of our tabs that's going to wrap around the end of the wire, and this is the end of the tab that's going to wrap around the insulation. Now they said not to exceed this point because you need to leave room for the actual pin to insert, right? So I need to make sure that my wire here isn't too long. Actually, it's way too long. You see that? It's too long. So I'm actually going to have to trim this a little bit. So let me just trim this wire a little bit. So we actually don't need to expose that much. It's just going to be probably that much should be it. Let's take a look again. Yeah, that looks about right. Okay, I'm just going to lay it in there. This is the hard part, getting that initial crimp on. So they said to use the 1.4, right? So I'm going to lay it like this. Okay. Oh, I completely missed it. All right. I'm starting to fray again. Let me twist these wires together to try to get it together again. Oh, I missed it. I'm sorry. It's hard for me to like try to do this. I'm trying to keep it in the camera while actually seeing what I'm doing. Try a little bit more.
You need somebody to hold the iPod?
I think the iPad's doing all right. Yeah, I appreciate that though. You know what I'm gonna do is I'm gonna try a different approach. Let me see if I can crimp the outer ends first. So I gotta line. Sorry, the angle is terrible. I gotta line it up first with the wing. Okay, you see that? There. I just crimped that. Okay, good. I actually got that. Look at that. Now, let me crimp the actual middle part. Now that I don't have to worry about. So they said to do the 1.4, which is this one. Okay, there it is. Do you see the two crimps?
Yeah.
All right. I think I should have left more wire. I'm a little concerned that's actually not.
Because did the second crimp grab insulation?
Yeah, the second one just grabs insulation, and the first one's supposed to grab wire, but
Or that's what I meant in the first one, did it also grab insulation?
no, I see here that the insulation ended. You see right there? But I just can't see any wire pieces sticking out from that farther one. You know how we can test to see if this actually did grab wire? Any ideas? Yes, continuity. What size wiring does this look like? I think here's our options. We could probably use the smallest one, right? 16th is a little too small. I mean, let's just take a look. Let's see what fits. So I'm just gonna use the red one. Yeah, this one's too small. I'm just going to use the red one as kind of our test pilot. Is I need to slip it over. Yep. Okay, perfect, like that. Okay, so I'm just going to pop out that other one again, the middle one again. Come on. All right. And then for heat shrinking, we're just going to cut the length that we need, not much. So,
I had a question.
yes.
Do they actually make a tool? I know the screwdriver works. Do they make a tool specifically to fit in that slot there to push down those little bars?
Good question. I don't know of.
It's like a little.
You know of it?
Yeah. Yeah.
What is it? What is it called?
I have no idea. We had to use them for when I was doing servicing machines on the green line, the red line.
Okay.
We had to change out the leads and the pins.
Oh, really?
Just pop, pop, pop. They actually have
I
a
use a
booklet.
screwdriver too. You gotta make a tool.
Yeah, I'm sure there's a more official tool.
Little metal.
Like technically, the crimping I showed you could be done manually, but man, that would be such a pain in the butt because that's like really specific. It has to be like 2 actions at once. So that was worth buying for me. Okay, so yeah, I'm sure there's a tool. So I use this one, the 24 to 20 AWG, or the actual diameter is 332, 364. And then I slipped it on just like you see right here. And now I'm going to just apply some heat to it. So the heat gun was on this table, right? Alright, so just apply some heat to it. This is just a hair blower, you know. And you can see it shrink. Alright, it's done. There it is. So instead of, that was a lot easier than re-crimping. Plus, it's a decent amount that was like exposed, so it would make it significantly shorter. So I think this is the better path, is to just protect the existing wire. Alright, now I just slip it back in again. Okay, there it is. Let me make sure I actually put this in the correct order. You can't tell by looking at the voltages. Well, actually, technically you can. If you cross wired it, you can tell. But if you cross wired, but it's like sequential cross wire, you know what I mean? Like, if you cross wired it so that you wired like 1 and 3, you can tell because it's going to be like a 7 point something volt. But if you cross wire like 1 and 2 and 2 and 3, but in a backwards order, you can't tell because the voltages are still going to be within that range.
The circuit battery balance tester that we used last
Yes.
week,
Yes.
would that identify if something was crossed?
No. Okay, well, there's only one instance. Okay, the instance that you could tell is cross-wired is if you did 1 to 3, it has to go through 2. Because physically in the back end, so what we're soldering and fixing is the colored wires here.
Yeah.
But look, we're not adjusting this. This is still, 1 is still physically attached to 2, 2 is still physically attached to 3. So if you cross-wired, let's say, like you somehow put wire 2 and 4 next to each other, what voltage are you going to read then?
Only 2 cells.
Remember, this is in series. So where does the blue go? The blue goes to this, which is the same as right here.
Yes.
And then the red goes to here. So you're reading the voltage between this point and this point, which is going to be double of what you're normally supposed to get, which is 3.5 to 4.2, right?
Yeah.
So that's the instance where you'll see you cross-wired it. But okay, look at the order we do it in. 1, 2, 3, 4, which corresponds to 1 and 2 corresponds to cell 1, and then we have 3 with cell 2, 4 with cell 3. If you did it opposite, where you did 1, 2, 3, 4, you won't be able to tell you cross-wired it because like it's still going to still read like 3.7 each. I guess technically it doesn't matter if you do it all backwards because what we just want to make sure is that we can read each cell. But yeah, things are going to be backwards. What matters more is like, okay, this is only a 3 cell, so you can't really like, you can't have that problem on a 3S because if you have a 1 to 3, it's evident, it's very noticeable. But let me show you an example of a 4S battery where it is possible to do like, let's say you wired like 2 and 3 on the outside. It'll be kind of obvious because now the wires are like obviously crossing in real life. So I was just trying to think of a scenario. I don't think it's gonna be there should be like actual like ways for you to tell. But my concern was like you put 2 and 3 instead of going in the middle, it was on the outside. But then you're gonna have one dangling wire on the very outside and then somehow like cross it back in again. Maybe if you didn't notice, you can let that slip by. But just by looking at the actual battery, you can kind of tell the areas that the wires are coming from. And then the actual validation, like you said, with the reader would help. So if I get one of those meters, I'll be able to look at what we have so far. So it's going to be a combination of looking at your physical wire layout and then also validating that your voltages are still within range. So let's take a look at what I have here. Now remember, I don't have this one wire, so it's going to not read a 4S voltage. It's going to be missing one of those, which is fine. We're just going to check the per cell voltage. Okay, yeah, that's what we did not expect this to be this, right? Look, it even thinks it's a 3S because we're missing one of the wires. Okay, but let's just check each cell. So the first, it says, okay, so all we can tell is that they are within normal range. They're not the 7 point something that would happen if you happen to skip a cell. And then the only other way to tell that you didn't crosswire is just by looking at it. Like you see the wires coming out of this thing. If I was to lay it flat. Oh wait, I think, oh no, never mind. It's hard to tell because it's all black. But you can see none of them are crisscrossing right now, right? None of them are crisscrossing. And ignore this crisscross, but it does straighten itself back out again. See, those are all lined up. So that's the other way. It's just... okay. Any questions? See, we just saved ourselves... I mean, batteries are expensive now, right? So we just saved ourselves from throwing away a perfectly fine battery. It's just the wires that was chewed up. So some of you are missing batteries, and here we go. We can give you back the batteries. Now, I did mention previously that if one of the cells is broken, then you have to actually go in and you have to like take apart the casing, and then you have to remove this wire. Let's say number 2 is bad. You would have to remove this wire, put it to 3, but in the meantime you have to desolder the existing wires. You also have to remove that green wire. It no longer exists. You have to shift all these other ones so that it closes the gap. That's not the problem. The big problem is that you're at risk of like actually having some like, you know, not explosion, I would say, just like a little fire, you know what I mean? Like so we're not going to do that in this class. And honestly, I don't think it's really worth it. Yeah, but yes.
Is there a danger soldering the lead of one of those individual cells? Is that what you're talking about?
Yeah, that's what I'm saying. Yeah, I mean, it's also like you accidentally like the same thing can happen here. That you accidentally short them. Yeah. Or you put it in backwards, you mixed up plus and minus, and you started soldering it together and stuff like that. Yeah. So there's more dangers when you're actually dealing with the individual cells now.
I mean, how sensitive are those leads to heat? I mean, if you're trying to, like a solder it, and you touch it too long, is that thing gonna overheat and explode in your face?
I think, yeah, if you expose it too much to heat, I'm sure it will. Yeah. So you want to be careful, yeah, like,
I know you want to be.
yeah, so don't dwell too long with your soldering iron on the battery.
You've never heard of any accidents happening?
I don't know of. Yeah, I don't really know of people that actually go through the trouble of repairing batteries like this. Yeah. Has anyone done this? Repaired the batteries to this extent? Yeah, to me it's like it's not worth the risk, so I just leave it as is. Yeah. Yeah. I mean, technically you can still use this. What you could do is you can identify the bad cell. And here's how you can use it. You can only use it in like low voltage applications. What I mean by that is not on a drone, because at that point we're just going to be using the battery leads. Let's say, okay, let me go to this example. Let's say cell number 2 is bad. What I can do is I can still create a 2S battery by just using cell 3 and 4. Because those are still next to each other, and I ignore the fact that 1 and 2 exist. 1 is on its own little isolated island, separated by cell 2, which is dead. So I just use 3 and 4, and then I just take out the remaining leads that no longer is applicable, and I just have a 3-lead system. But that's another way you can repurpose it without risking like taking the whole thing apart and actually trying to remove that bad cell. There is Oscar Lang, he's one of like the website FPV like people. He has an article on this, how to repair. It says repair lipos. You can read it, but he even says right here. Like it's not recommended. So, but basically he goes over the same thing. He's like, you can expose it right here, and then you take apart that one cell that's bad, like they did right here, and then you resolder everything back together. I guess that's where I stole my image from. Yeah, that's a whole process here. I've tried it before. It's like I don't think it was worth it. Yeah, I did it. I did it successfully on one of my batteries. I'm just like, oh, that was like a pain in the butt though. Okay, I'm going to leave this kit out. I would say maybe before you do it on an actual battery, try it on a wire and just see if you can get it to work. This is my own crimping tool, so that's why I only have one of them. So I'm just going to pass around this. So if you want to give it a shot, you can. And then once you guys are ready, just let me know and I can have you try it on the actual battery. So whoever wants to try it, I'll just leave this at the edge of the table here. And then we're going to continue on.
Yeah.
Okay, we're going to continue on with building the drone. Now, for the majority of you that are using the classroom kit, remember how last week I was saying like, oh yeah, the motor screws are a little too long, right? Are they too long or are they too short?
They're
Too long. What were they, by the way? Do you remember what the size was?
Yeah, it was a 7.
Okay, because I bought M2-6. So yeah.
Yeah, you bought M2.
And then you're going to use the ones that is too long for them is perfect for you guys, okay? All right, perfect. So, yeah, go ahead and get your kits. Oh, before I do that, reminder, since some of you walked in late, there is a homework that's due today. So just take a look at that. And then next week, we also have the midterm. Okay, so that'll be here in class. That is going to be on everything we went over up to this point. So that's why I'm not really introducing much today, because I don't want to overload too much. Do you still have access to your previous homework and quizzes?
Yeah.
Okay.
Quiz 3 to get
Take a look at those. Yeah. And then also the videos that I record all the time. Yeah.
I got to check for the homework though.
You're happy,
So right here we have a brace. This brace attaches to the duct of the drone, and it breaks often when you crash. And since we don't have any, I'm going to be designing it from scratch. So first thing I got to do is, since I already have the part, I'm going to just get some dimensions. So how do we get dimensions? We got to use a caliper. Caliper is a tool that you can measure internal distances, external distances, and such. All right, everything I do here is in metric, that being millimeters. And because it's probably designed in millimeters, so what I'm doing here is like reverse engineering it, trying to figure out what the initial specs were. So let me first just measure the total, measure what the total width is.
Could you do that with LiDAR?
Yeah, you could.
So on my
Yeah.
on my iPad, and I think on the new iPhones, they have a little LiDAR scanner.
Yeah.
And you remember that CAD software on chip I was telling you about like week 1 or 2?
Mm-hmm.
You're able to do a full LiDAR scan of objects and then port them directly into the CAD software.
Oh, nice.
Yeah.
Yeah, that's an option too. I'm doing it kind of old school way.
Oh, absolutely. It's important to learn.
Because the reason I still do this is because I want to natively create each of these shapes. That way, if it's like instead of 2.7 millimeters, 2.8, I can just enlarge it.
Exactly. No.
Yeah, but if you're just purely trying to like create a copy of it, that where dimensional accuracy does not matter, then sure, the LiDAR will probably be okay. But since here the hole spacing is actually really important,
Right.
because otherwise it's literally not going to fit on your thing,
Exactly.
I'm going to have to like measure it. But yeah, that is an option. And sometimes that's your only option if you're like dealing with bigger stuff. Normally when you measure things with holes like this, it's best to do from hole center to hole center, because ultimately that's the distance that matters.
I've always had a hard time getting like the hole center. I just kind of end up dropping the little veneer caliper prongs into the holes.
Yeah.
And go off of that.
And then you have to subtract the radius of the hole though.
Exactly.
If you're going to do that.
Yeah.
Which I can do right now. I was just kind of approximating. I see right here 139, which doesn't sound right to me. I just want it to be 140, but it's 139. But let me just double check anyways. No, 130 would be way too...
No, I said 140.
Oh, 140. Yeah, you're probably right. But right now I'm reading from the outer hole to outer hole. I'm reading 141.5. Man, it's gonna be difficult. Actually, if there's an actual drone, I can also measure. That's the other way. Since this actually mounts to a drone, I can just. It's the same thing though. Same issue. Oh no, it doesn't mount to that. This. Yeah, but it's the same issue actually because it's still not like I have an actual point. I'm just gonna approximate it, and then this is again where the beauty of the 3D printing is later. If it's off a little bit, I'll just make the correction and just reprint another one.
Do we have any plans of getting resin printers?
Not that I'm aware of. So I have here 130. Yeah, 139. Weird. Okay, whatever. Next thing is I'm going to measure the height like this. $29. Okay. I'm just rounding everything, even though I'm getting like point something, but to me at that level, it's my tool. I don't even think it's that accurate.
What decimal do you usually go down to?
For this right now, I'm just doing. I'm not rounding it. I don't do a decimal just because I'm not 100% sure like where this should sit because I'm trying to measure the virtual center of this.
Yeah.
So like that's why the decimals I just kind of ignore.
Okay.
And then I'm gonna print a copy and I'm gonna see how it fits and then I'll make a little adjustments. That's kind of what I'm doing. And if you guys ever need help with something, just let me know. I'm just kind of doing this.
If anybody on my side wants to get a picture I've taken off the top of the model drop, you can see what you need to pan or solder on the top board.
Let me know when that happens so I can take a photo too.
What?
Let me know when that happens so I can take a photo. Oh, you already did it. Okay, I draw the piece. I think I got all the dimensions. We shall see as I start building this thing. Now this thing is symmetrical about the center, so I'm just going to draw half of it about the vertical center. So I'm going to draw half of it and then I'm going to mirror it. So let's take a look here. First I'm going to create a sketch. To me, the way that this thing is oriented is flat. So the best sketch for me to draw on is right here, the XY plane. This is my origin, so I'm going to reference that. Oops. I'm going to XY plane. Do a line tool. Let's start here. Now I have here 104. 104 is the total width here. But I'm drawing from this circle point. Or actually right here, this bottom edge. So it's going to be... Okay, let me do this. Let me delete that. Let me start up higher. That's going to be 104 divided by 2 because it's half of it. Then I'm going to go up. I'm going to create a curve like that.
Can you specify the radius?
Yes, I can. But right now I'm just going to keep it open-ended because I'm going to constrain it later with actual dimensions. So I'm just going to go like this. Now, let's put some constraints on this. Constraints is just telling geometric relations. So these two have to be parallel. Okay, so I put the parallel symbol right there. This curve to this line needs to be tangent, just like you see right here on the other one. There it is, it's tangent. See, I start moving things around, and it always stays parallel, it always stays tangent. Now I need to define that the
way my high school CAD teacher kind of taught us was those symbols are the same as like in electronics, the different little like diode symbol and the different little ones. So if you learn those and you learn the hotkeys for it on the laptop, that's the key to doing things quick.
Wait, repeat that. Okay, I'm gonna make these horizontal vertical. So now no longer can I stretch it farther. I need to make these midpoint. How do I do that? Okay, let me do this. I'm gonna put dimension right here. The radius should be what I wrote here. The distance is 7 millimeters, so the radius is going to be 7 divided by 2, like that. This is going to be 7, but I want to put this like, I need a, here. Is there a way? Okay, here, I'll just do this. From here to here is going to be 3.5. So now center's about that point. This is too tall, so the height is 29 from the bottom to there. So from the top to the bottom here. Oh, see, everything they do is per the center of the hole. That's fine. It's gonna be 29 minus 3.5, right? Because that's a radius. 29 minus 3.5. And then, this is still blue. So black means it's fully constrained. Blue means it's not. Okay, that's what's not constrained. I need to constrain 139. So 139 is from center hole to center hole. 139 is from 139 from here to here. 139 divided by 2 though. There it is. Now it's all black. Black means it's fully constrained. Let me put some points on there. I'm going to put a point. We have a point right here already. I need another point right here. Okay, so the other point right here is 107 from point to point. So that's going to be from here to here. 107 divided by 2. That's the point. Alright, now we can do a mirror. So I'm going to copy all this, or I'm going to select all these. I'm going to do a mirror. It's going to ask us, what do we want to mirror about? I want to mirror about this green line. That green line is going to be the y-axis. And there we go. We just created a copy. Just like that. Everything is still black. That means it's fully constrained. I just exited out of the sketch. Nope, it is not fully constrained because this does not turn a lock. Once it turns into a lock symbol, that's how you know it's fully constrained. I think it's because this thing is not fully constrained. What is not fully constrained? I wish it told you. What is not fully constrained? Alright, well, we can still work with it even if it's not fully constrained. Now I'm going to extrude it. The thickness, which I didn't measure yet, the thickness of this thing is going to be 2 millimeters. So I'm going to say distance 2 millimeters. There's that part, just like that. Let's turn to the top. Let's turn to that view. Looks about right. Okay, so previously I put holes on here. If I unhide it with the eye, you can see if I go to the top view, you can see that I put dots right here. That's where we're going to put some holes. So I'm going to put the hole right here, here, and here, and here. Now with hole tool, you can specify some parameters. I'm going to do through all. It's going to cut all the way through.
And it'll thread it?
Yes. I'm going to do, it's going to be a 3 millimeter diameter hole. Right? That's what I said here? Okay, good. Okay. That is, those 3 holes are not threaded. And I'm going to do a separate hole command because these 2 holes are threaded. So this plus this. This plus this, those 2 holes are threaded. This time it is going to be tapped. It is an angled drill point. I see it right here. Okay, so here it's an ISO. It's a 2.5 millimeter. There it is. Isometric. Okay. Objects to cut. We need to cut into the actual piece, which is the body. Press OK.
You have another set of verniers? I might need to recount a piece.
Yeah, they're over there. There's a stack of them. This has a radius right here. I see right here it has a radius. So actually what I could have done is I can make that radius from the sketch. Fill it. And let me fill it here and here. I don't know. I'm just going to approximate it because it's kind of hard to measure a fillet. Oh, I thought it would do it on both sides. I guess not. I was hoping it would do on both sides. Okay. That's it for the fillet. The interior corner doesn't have a fillet. This thing also has a raised piece.
So wait, I got a question.
Yes.
Did it make a uniform?
Okay, we also have a raised surface right here. So I'm gonna just measure how much it's raised. I already know that my this arm itself is 2 millimeters, so I measure the whole thing with the raised, 3.26. So that means I added another 1.2. I'm gonna say 1.2. I round down because generally 3D printer makes things slightly bigger, as actually he's finding out right now. It's slightly bigger. So I'm just gonna do 1.2. So here I happen to have my sketch with the hole. Remember the dot I created in my initial sketch right here? I'm gonna reuse that dot. So I'm going to sketch on top of this XY plane. I'm gonna make this. Oh wait, I need to find the diameter of it. 5.5, okay. 5.5. Here, let me do it on this side and then I'll mirror it once again. I'll just do 5.5. 5.5. And then I'm going to make another one that's just going to go straight to... Darn it. Okay. I'm trying to grab the edge of this. And you could do is... You can project an existing feature. So that is in a different... That's not part of the same like sketch. So I'm just projecting this. Now I can hide the body just to show you. You see, I created a projection of that. So I'm able to reuse actual 3D features. Okay. This and this needs to be concentric.
He's building what's called an traffic system.
Okay.
Essentially, there's a national, public base of different nodes that he's talking to. Oh, wow.
I'm going to create a mirror. There's my object. My mirror line is going to be the y-axis. Y-axis. Why is it not working this time? Why is it not working this time? It's weird. Okay, I'll just create a temporary line then.
Yeah. There goes on the bottom.
Okay, profiles. I'm gonna do sketch 2. That's what I'm trying to... Sketch 2. Let me turn off sketch 1 and the body. Alright, try this again. I'm trying to do this profile.
Yeah, exactly. I mean,
Okay, there it is. I want that.
it's making the satellites cheap. Getting it up there is expensive.
I want that. offset from this surface by 1.2 millimeters. Oops. Oh my gosh.
The furthest or the longest a message has been sent on the record for it is 3,000 kilometers. It's using a 3,000. Yeah, that's for a meshtastic, not for drone. That's for a message. Yeah.
So you're not using that one?
It's really cool. Yeah, that's my next project. Is I really want to build one. But pretty much the entirety of the United States is completely covered. Yeah, I'm just loading right now for you guys. Oh yeah, there you go. Right there. And so basically, wherever you are, you send it, and then the message bounces from those repeaters, and it keeps bouncing until it reaches its destination. Yeah.
Is it encrypted?
It's encrypted, untraceable. Yeah, it's so nobody can tap into your messages unless you're, unless they're part of that message chain.
I found someone.
What were you doing?
I found a node.
What does that mean?
Another guy has one of this, and I can discover him, and I can send message to him.
So it's like a private network or
Right,
something?
yeah.
When do you use something like that?
When the cell tower's down.
Oh.
When there's no internet.
Can you call, or is it just like messages?
It's messaging.
So you talk to that person?
I have not. It wasn't successful. It says maximum retransmission reached.
Interesting. You sure it's not like the police? Or it's like...
And I've been sending them like, hi, how are you?
As long as it's not like, where's the drop? Or something like that.
I'm sure someone's listening.
Or they're like one of the engineers. Did you just buy that? You don't have to like actually build one, right? You just buy it?
I just buy this and I can do like a couple of libraries. I can put GPS on it, LCD screens.
Oh wow.
And the more I have it, the more network. It's like me building a cell tower.
Right. Dang.
And they were talking about maybe Starlink is something like this.
Uh-huh.
Right? You send out the node in the airspace.
Yeah.
And the node talks to the node. And it talks to you. And they probably have a big GNSS station.
Yeah.
And then when you send the messages, that tower
that thing
talks
does
to the
it.
node and to another node.
That's crazy. Show me how to do that.
This is only 25.
That's it? Although, at least if we do it to my own, then, well...
Can you have multiple?
That's a good question. Actually, I don't know. Alright, this looks good now. I'm gonna just 3D print it. Okay, save this thing. File. Save as. Or I'm gonna export it.
Yours to stay at 750.
They're not PLA.
PLA is really hard.
How do you turn it? Pressing the button.
Is it okay if I bail in like the next 30 minutes?
Yeah, that's fine.
I gotta study for a midterm.
Yeah, that's fine.
Is there any assignments I should do? I know there's a
There is
quiz.
still a quiz, and make sure you do the assignment.
I
That's
did it and turned it down.
Yeah, it's fine.
Okay.
What is it? 5 o'clock already?
Yeah.
Yeah, I mean, I was going to probably show Beta Flight next, but you already know how
Are
to
you
do
gonna
that.
pin? Are you gonna pin tune?
No,
No. Are you gonna go over pin tuning at all in here? No. Okay. That's like the only thing I want to learn on.
I don't even really know.
I know it's like esoteric art.
Yeah.
Yeah, I'm pretty solid on Beta Flight.
So I took that part, I exported it as an STL. We have back here Ultimaker method. That's method X, that's the printer we have. We're going to drag in this STL. And let's print a couple because there's a bunch of... How many of you guys are missing this? Alright, I'm just print a bunch. Print. I think I can only fit maybe 5 in. Wait, I could fit more in. I just need to squeeze it. This wasn't efficiently packed. It needs to be nested like Russian nesting dolls.
So this is a Pixelhawk 4D. And this is essentially makes this drone completely autonomous. So you would the software I use programmed in high school with RV Pilot. And you can essentially draw out a mission plan just like you did when doing the mapping class, right? And then it will it'll do it. Did you make the Pixelhawk attachment for this?
No, that was already here. I don't know who made that.
Is that still a standard that they use?
I haven't seen anybody change it because the thing is, everybody that's like doing it commercially just ends up building their house. Yeah, they just kind of take part of this. They don't need.
Alright, I'm gonna print 7.
Extra ports. You know what I mean? Exactly. Probably the basic rock code out of it, and then
Yeah. The one without the screen.
Yeah.
It's gonna take 5 hours to print this. No. I put it at a pretty high setting, so expected. Alright, because our printers are offline, I'm just gonna take a USB stick, save it on the USB stick, shoot it over to the to our printers over there. States removable. We need 31 grams of material. Okay, let's go over to 3D.